We have walked on the surface of the moon, tunneled through the ocean floor to connect continents, and built skyscrapers that pierce the clouds. But what if we were commissioned to build a perfect one-to-one working replica of the Great Pyramid of Giza today, using modern technology? This 3D scale diagram illustrates the true weight of the problem. A structure 147 meters tall, spanning a 12-acre footprint, and weighing exactly 6 million tons, the mass equivalent of stacking 6 million modern sedans. To figure out exactly what it would cost to build this mountain of rock in the year 2026, we have to draft a step-by-step construction blueprint, factoring in the required land, labor, and logistics. Modern technology makes the math easy, but the physical reality of moving 6 million tons of earth and stone remains a massive hurdle that engineering alone cannot bypass. Placing 6 million tons of rock directly onto desert sand results in immediate structural failure. The weight is so concentrated that the entire monument would sink and collapse into the earth. Before a single block is laid, we must purchase 13 acres of highly stable tectonic bedrock. Then, we run deep seismic scans 200 feet below the surface to ensure earthquake resilience, and use GPS-guided bulldozers to laser level the ground to a strict 1 millimeter tolerance. Because we cannot rely on raw bedrock alone to support the extreme vertical pressure, we have to pour a 4-meter thick reinforced concrete mat. This requires 500,000 tons of concrete, enough to exhaust several fleets of mixer trucks over 3 years of site preparation. This financial dashboard tracks our running expenses, factoring in land acquisition, deep scanning, leveling, and that massive concrete foundation. Our Phase 1 receipt hits $550 million. We have spent over $500 million, and we haven't even laid a single stone. The Great Pyramid requires 2.3 million individual stone blocks, ranging from 2 to 60 tons apiece. If a modern quarry used their standard equipment to fulfill this order, it would take over 60 years. To meet a 5-year construction deadline, we need 250 industrial diamond wire saws operating simultaneously inside the stone quarries. This data visualization shows the massive power requirements of our cutting grid. These saws drain 20 megawatts of energy every single hour. Over 5 years, that equals the daily electrical consumption of the entire country of Italy. By zooming out on this map to view the transport route, the bottleneck becomes clear. Moving these blocks from the Aswan quarry, 900 kilometers to the build site, requires a continuous loop of 2,400 heavy-duty trucks, with 500 of them on the road at any given second. Updating the project's financial dashboard adds $1 billion for raw limestone and granite, followed by millions more for cutting machinery, electricity, and continuous transportation fees. Extracting and moving the materials for the pyramid requires a supply chain footprint that rivals a modern military deployment. Now we face the final bottleneck, taking 80-ton granite blocks meant for the King's Chamber and lifting them 147 meters into the air with precision. The laws of physics strictly limit modern construction equipment. As a crane's lifting arm extends further outward over the pyramid's massive base, its weight capacity drops drastically.
To bypass this,
we must assemble a massive network of the world's largest tower cranes, constantly disassembling and raising them as the structure grows. Securing and maintaining 10 of these massive cranes costs $300 million alone. Add in the salaries, safety insurance, and food for an army of 3,000 highly insured workers over 5 years, and we add another $400 million to the bill. Ancient builders used ramps. We use tower cranes. Yet suspending a granite block the weight of a passenger jet 40 stories high is an operation where a single mechanical failure ensures total destruction. The final architectural step is wrapping the entire structure in 115,000 blocks of glowing white Tura limestone, ensuring the surface is perfectly flat and reflects the desert sun exactly as it did 4 millennia ago. This final financial dashboard locks in the total sum. When we add the land, the foundation, the stone, the transport, and the labor, the modern blueprint costs $2.95 billion. To put that in perspective, Almost $3 billion is roughly what it costs to build SoFi Stadium in Los Angeles, one of the most expensive modern megastructures on Earth. But a stadium generates massive ticket sales and broadcasting revenue. Modern megaprojects are strictly driven by financial return on investment. The ancient Egyptians poured immense resources and engineering into a project that offered zero economic return, driven entirely by spiritual conviction. The Great Pyramid remains an anomaly, a structure built by a society that valued spiritual preservation more than the economic logic of its own survival.